example, if you have a function f of x and if you add a number outside the function, if you add a number outside the function, let's suppose the number you're adding outside the function is a. Now, this is going to result, this is what happens to the function, and this is what happens to its graph. Its graph will shift up by a units. It will shift up by a units. So there is no change in the x. It will go up by a units. You can describe this up by a units. Or you can just simply write it down as upward movement. Okay, upward. If you have a function f of x, and if you subtract a number from it, like outside the function, then again, you're making changes in y outside the function. That again, it will result in the vertical transformation. Now, this is going to result in, this is what happens to the function, and this is what happens to the graph. It shifts down by a unit. So that is why I've written here the negative of a. So you can write it down by a units. I haven't written minus sign here. Okay, this minus sign only represents the direction of the movement. Minus a means you need to move down by a unit. So down by a units. Horizontal translation. F of x, if the horizontal means you're going to make changes in the graph along the x-axis. So you need to make changes in the x. So if I subtract, let's just start off with adding a. Now, our first instinct tells us that if something is being added inside it, because we try, so basically why does this happen? Because in vectors, when we say it's plus a, so something is moving towards right. But when we write it down with the function, if it is plus a, the behavior is actually the opposite. So this means the graph will shift horizontally to the left by a units. There is no vertical change, so the y component of the vector is going to be 0. So you can describe this as left by a units. Next thing is f of x minus a. Now this means, again, the behavior is going to be opposite because I am subtracting a from the x, which is inside the function. So apparently it looks like the graph is going to shift left, but in reality, as you know, whenever you're doing a horizontal transformation, the behavior is opposite. So the graph in reality is going to move to the right by a units. So you can describe it as right by a units. Okay. Now the important thing in translation, the only thing where it gets a little tricky is this part. Plus a, you should remember the graph is going to move to the left. Minus a, you should remember the graph is going to move to the right. Now here I have explained the horizontal and the vertical transformation separately. Okay, it doesn't mean you always have to do like this. You may get a question in exam where you get both the transformation, horizontal translation and the vertical translation together. Exactly in the same way when you are actually describing transformation, and if it is both horizontal translation as well as a vertical translation, you can just write it down as one single translation. And while writing down the vector, because in the vector you have the capacity to write down the horizontal and the vertical component both. Okay, so let's just combine them together. So if I combine both the transformations together, both the translations, a horizontal and the vertical one. So this is how it is going to look like. If I have the function f of x, and if I do it x minus a and then plus b, this means that the function is, now this is minus a. What does this mean? Plus a or minus a in the vector? Plus a. This is plus b, this comes down as it is. So this graph is going to go a units right and b units up. Okay. All right. Just for the sake of revision purpose, what is actually the translation? How does it affect the diagram? So for example, if you have this triangle A, B, and C, and if the examiner draws another triangle here, which transformation is being applied from this triangle to this triangle? Translation. Can you help me write down the vector for it? 0 for the x. For the y, it's 0 because there is no vertical movement. So you need to check how many units it has moved to the right. So it started off from here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this point here till this point here, 11 units to the right. So the vector is going to be 11, 0. Okay. And the question can come vice versa. You've been doing this in your IBCSE. Okay, and let's just apply it on functions. The way we started off yesterday, can you draw the graph of x squared? The very basic simple graph of a quadratic. So let's suppose the function is x squared. Remember, we can write down this function as there's nothing being added or subtracted inside the function and there's nothing outside. So what are the coordinates of the vertex here? 0, 0. Is it going to be upper parabola or the lower parabola? Upper parabola, shabash. It is going to be upper parabola. Happy face. All right. So I suppose you all have drawn the graph of this basic quadratic function, and this is how it should look like. So this is f of x. Okay. I'm going to give you another function, g of x. Can you draw the graph of x minus 3 whole square? Just minus 3 whole square. So remember, if it is just x minus 3 whole square, what are the coordinates of the vertex? 3 and 0. Shabash. Draw the graph of g of x. We're only using the concept of quadratics here, okay? Do it on the same grid. So let's suppose 3 is here. Is this what you're getting? Okay. Now, as the coordinates of the vertex from here, you concluded that they are 3 and 0. This is the basic concept of a quadratic, which we've already studied. So this is how its graph will look like. Now let's connect this with the transformation. If I ask you to connect this function with this function, isn't g of x actually f of x minus 3? G of function, the g of x function, what is it? If you compare x square with x minus 3 whole square, isn't it the same? अगर आप फंक्शन f में x minus 3 करेंगे, x की जगह x minus 3 लिख देंगे तो वही चीज आ जाएगी या नहीं आएगी? So g of x is actually f of x minus 3. So if you recall the previous page, when you subtract something inside the function, you're trying to make changes in x. So that is basically a horizontal translation. Now minus 3 means the opposite behavior in a horizontal translation. So the graph will shift 3 units to the right. हमने ट्रांसलेशन नहीं अप्लाई की, हमने सिर्फ क्वाड्रेटिक्स का बेसिक कॉन्सेप्ट यूज करते हुए ग्राफ बनाया एंड वी रियलाइज दैट दिस इज एक्चुअली ट्रांसलेशन का भी यही कॉन्सेप्ट है. ठीक हो गया? Now if I ask you that h of x is a function which is basically f of x plus 4, f of x plus 4 क्या होगा? What will be f of x plus 4? You write down the function f and replace the x with x plus 4. So this is h of x. h of x आपके पास क्या है? x plus 4 whole square. अब x plus 4 whole square means f of x plus 4 का क्या मतलब है? इसको छोड़ दें. इसका क्या मतलब है? f of x plus 4 फंक्शन के अंदर 4 ऐड कर रहे हैं x के साथ. What does this mean? Just explain me this part. 4 places to the left. 4 places to the left. So अब quadratics वाला भी concept apply करके check कर ले. इधर vertex के coordinates क्या है? -4 0. So this was the function f of x. So ये 4 units यहाँ पे आ जाएगा. Okay? Yes, online students. Clear है यहाँ पे?
Yes, sir.
All right. Okay. So let's suppose you have a function x squared plus 4x plus 8. X squared plus 4x plus 8. ठीक हो गया? एग्जामिनर आपको कहता है कि f of x, या चलें ये नहीं मैं आपको कहता. एग्जामिनर आपको कहता है जी इसको ट्रांसलेट करें बाय अ वेक्टर 3 minus 2. ट्रांसलेट करें बाय वेक्टर 3 and then -2. अब आप मुझे ये बताएं, this 3 up here, what does this mean? So what does this mean? +3. वो फंक्शन के अंदर वाली जो चीज होती है उसको ऑपोजिट देखना होता है. अभी हम फंक्शन नहीं लिख रहे, ये मैंने वेक्टर लिखा है. दिस इज अ वेक्टर, दिस इज नॉट अ फंक्शन. So what does this +3 means here in the vector? 3 places to the right. So function में मुझे इसको उल्टा लिखना पड़ेगा because I'm writing down a function. ठीक है? Okay. What does this -2 means? -2 means 2 units down. Okay. So we know that the upper part here is the horizontal translation, which is going to take us 3 units to the right. And this part down here is the vertical translation, which is going to take us, shift the graph 2 units down. Now, let's write down the function notation first. The 3 units to the right, what will change inside this function or outside this function? What changes should I bring here? The upper part only first. Plus 3, x minus 3. So I'll bring changes inside the function. Horizontally change करना है. Horizontally move करना है means you need to bring changes in x. So that is opposite behavior होगा function के साथ, तो then minus 3 लिखेंगे. Then minus 2 vertical shift लेके जाना है उसको, vertically move कर रहे हैं along the y axis. फिर क्या करना है? Minus 2. So this is what happens to the function. Okay, so this is the function, the new function g of x. Okay, so let's write down g of x now. So g of x क्या होगा आपके पास बेटा? According to this function notation which we wrote down, according to this, we are going to replace all the x's with x minus 3. And outside the function, what do we need to do? Subtract minus 2 from the entire function. Okay? So wherever you see x, replace it with x minus 3 plus 4 x minus 3 plus 8. Now this is the function. From the entire function, I was supposed to take away 2 as well, minus 2 from the entire function, outside the function. Okay, this is g of x. Now you need to simplify this. So this is going to leave us with x squared minus 6x plus 9. I've expanded this using the basic algebraic identity. 4x minus 12 plus 6. And if we simplify this further, x squared minus 2x and plus 3. यही आता है बेटे? यहाँ तक समझ में आया? हाँ जी रिता बेटे, is it clear?
Yes.
Okay. Now I'm going to write down few function notations. You need to tell me. You need to write down their vectors. ठीक हो गया? I'm going to do one example for you. So for example, I have a function, and if the examiner tells you to f of x minus 3, then the vector is going to be plus 3 and 0. So I'm going to write down the function and its notation. You need to write down its vector. Start करें? Okay. F of x and then minus 3 outside. What would be its vector? F of x plus 4. What would be the vector of it? F of x minus 2 plus 3. What would be the vector? F of x has become f of x plus 4, then minus 7. What would be the vector? Huh?
Yes, sir.
Okay. Abdullah, can you please share the answer? हाँ जी, पहले का आंसर क्या है?
-1 over -2.
माइनस
1.
-1.
Sorry, 0, 0, 0. Sorry, 0.
यस, पहले का आंसर है बेटा 0 एंड देन
-3.
एक्सेलेंट.
Next one, -4 over 0.
-4, 0.
2 over 3.
शाबाश, एक्सेलेंट.
And -4 over -7.
-4 and -7. Okay, very good, excellent. Okay, I would like to correct you here for one thing. The answers are correct. The way you were saying 2 over 3, many students say it like this. Okay, I understand it relates a lot with the fraction, but it is actually not. These are two separate components, x component and y component. You say -4 and -7. That would be more appropriate. Excellent. Is it clear up till here now? All right. So this is how you're going to read it. Now let's combine the reflection, which we did yesterday, with the translation. Okay? Should we do it? Yesterday I told you that when we're doing inside, when we are making changes inside the function, we don't say we multiplying this thing with the inside the function. We say it completely. We are multiplying this thing inside the function with x. Okay? Because only then the transformation, the horizontal transformation occurs if you bring changes in x, not just inside the function, because inside the function you have many other things. Now, for example, if I have a function f of x and first of all, identify what two transformations are being done here. Forget about the sequence. Sequence छोड़े रहने दें. जो जो नजर आ रहा है आपको बस वो बताते जाए. एक रिफ्लेक्शन, which one डिटेल में बताए कंप्लीट. Inside the function, inside the function मल्टीप्लाई हो रहा है ना माइनस साइन, इसलिए आप रिफ्लेक्शन माइनस साइन से तो आपने पहचान लिया. वेरी गुड, इट इज रिफ्लेक्शन. अब इनसाइड द फंक्शन मल्टीप्लाई हुआ हुआ किसके साथ? x के साथ. तो ये कौन सी हुई? हॉरिजॉन्टल रिफ्लेक्शन. ठीक हो गया. हॉरिजॉन्टल रिफ्लेक्शन को आप क्या लिखते हैं? रिफ्लेक्शन इन द लाइन. कौन सी लाइन होती है? y एक्सिस या फिर x इक्वल्स टू 0. ठीक हो गया. ओके, दूसरी और कौन सी हुई? ट्रांसलेशन. व्हिच वन? हॉरिजॉन्टल ट्रांसलेशन. हॉरिजॉन्टल ट्रांसलेशन. हाँ जी, वेक्टर बताएंगे क्या है इसका? -4, 0. यहाँ तक क्लियर है? ऐसे ही हुआ हुआ है जी ऑनलाइन स्टूडेंट्स. इज दिस, यही दो आपको भी यही नजर आ रही है?
Yes, sir.
Good. Because of this minus sign being multiplied with the x, you can say that it's the reflection, and +4 inside the function means this graph is being shifted to the left by 4 units. Now let's look at the sequence of it. क्वेश्चन, अगर अब आपके पास एग्जाम में क्वेश्चन आता है, एक फंक्शन को वो ऐसे लिख देता है, या फंक्शन नोटेशन नहीं देता, लाजमी नहीं कि वो आपको कोई फंक्शन देगा क्वाड्रेटिक लीनियर, लाजमी नहीं है. वो सिर्फ फंक्शन नोटेशन से भी आपसे पूछ सकता है. जैसे ये फंक्शन है, ये भी फंक्शन की नोटेशन है. सिर्फ एग्जामिनर आपको कहता है Describe the transformations in sequence. Uh, Definitely both of them cannot happen simultaneously. One of them has to be executed first. Now, which one took place first? What do you think? We're going to test and verify with both the possibilities where the horizontal translation happens first and then the reflection, and then we will see if the reflection happens first and then the translation. But what do you think for now? What happens first? So you're saying reflection happens first and then horizontal translation. Yes, Rida, what do you think? What happens first?
Sir, it doesn't matter. I think.
It doesn't matter. Okay.
Mhm. I'm
Yes.
not sure. Maybe it doesn't matter.
Okay. Abdullah, which happens first? Or it doesn't matter. Anything can happen first. Okay. Let's draw a function machine here and then we will see what is going on. Okay. Now, one of the possible route is that you have a function and then let's say you do the horizontal reflection first. आप सबसे पहले क्या करते हैं? F of minus x apply करते हैं उसके ऊपर, which is basically horizontal reflection. So उससे क्या फर्क पड़ेगा इसके ऊपर? F of minus x हो जाएगा. ठीक हो गया? Then you apply the simple translation. फिर उसके बाद आप ट्रांसलेशन वेक्टर के ऊपर अप्लाई कर देते हैं -4 and then 0, -4 and then 0. Now, as I stated earlier, whatever changes you make inside the function, you make changes inside the function in what? Inside function and then inside the function in what? In order to make changes along the x-axis, you make changes inside the function in what? In x. You make changes in. Now here we have two things right now. You're only supposed to make changes in x. This is how it is going to be. F minus sign. You're not going to make changes with the minus sign. You're going to make changes in x only. So I've added +4 in x because this is -4. So inside the function for the horizontal translation, behavior is opposite when you're writing down the notation. So this is going to be simplified as -x -4. That's one possible way. Another possible way is you do the translation first. You apply the translation first, and that will result in x +4. ऐसे ही. And then you apply the reflection, horizontal reflection. For that, you need to multiply the minus sign in x, not whatever is inside the function, only in x. That is going to result in -x +4. Okay, which one matches? Which route is the correct one? Yes, second is the correct, and the first is wrong. So one thing, the sequence does matter. Second thing, how to identify the sequence? The best way to go about it is, for now, I will tell you once we are done with all the transformations, I will tell you a shortcut as well, but that shortcut sometimes helps and sometimes it doesn't. So the best way to go about it is you should know how a function machine works. So you can always do this small working in the rough one. It doesn't take very long. It takes hardly few seconds. I was explaining here, that is why I took a little bit longer, but this is how it works. Is this clear? यहाँ तक clear है? Let's verify this. हम इसको verify भी कर लेते हैं. पहले बताएं ये वाला part clear हुआ है या नहीं हुआ? ठीक हो गया? So in order to obtain this particular transformed function, we know that there are two transformations being carried out. Now which one is correct? Second one is correct. First one is wrong. If we do the reflection first and then do the translation, we will end up with the wrong function. Okay. And if we do the reflection first, oh sorry, translation first and then the reflection, we will get the correct transformation. Now let's see. Let's apply this on a graph and test this. So I was saying, this is what I need. Minus x plus 4. I'm going to draw the two grids here in order to verify which one is correct. Let's take a point. I'm not going to draw a function or a graph. I'm just going to consider a point and we'll apply both the roots separately. The first one was, let's do the first one and see how it is wrong. Okay. We'll see that first of all, we will see that it actually matters. Here we have checked which one is correct. The second one is correct. Now, in order to explain the point that actually the sequence matters, let's do it on the graph. First of all, before we proceed further, if you're confident that, first of all, tell me please if you're clear about this, that which one is correct. If you have any doubts about it. The only muddiest point here is that you need to make changes in X. Okay, so that is why when I applied the transformation, I applied it on X not with the minus sign. So I kept minus sign outside X plus 4. When I opened the bracket, it resulted in minus X minus 4. Okay, now let's do it here. So let's suppose this is the point. The coordinates of this point are 2, 1. 2, 1. Let's do the reflection. Horizontal reflection. Reflection in the y-axis. This is 2 units away from the y-axis. Its reflection will be 2 units away from the y-axis on the opposite side. So this is where it is going to be. After that, 4 units to the left. 4 units to the left. Translation. 1, 2, 3, 4. This is where we end. Now, what are the coordinates for the final product? 1, 2, 3, 4, 5, 6. Minus 6, 1. This is what happens if we follow the first route without knowing which is correct and which is not correct. Let's see what happens if we follow the second route. Same point, whose coordinates are 2, 1. So if I apply the reflection here first, no, we did reflection there first. Okay, so first of all, we are going to translate it by 4 units to the left. 1, 2, 3, 4. So I have translated this point 4 units to the left. Translation done. Now the reflection part, reflection in the y-axis. This is 2 units away from the line of reflection. Its reflected image will be 2 units away on the other side. So it comes back to this point. So the final product has these coordinates. Over here, the final product has these coordinates. I have applied same transformations, but in different sequence. There, the final product is on 2, comma 1. Here, the final product is on -6, comma 1. So, order matters. The sequence matters. From here, we cannot tell which is correct and which is not. We can only justify that. We can only verify that and know which is correct and which is wrong by using a function machine. By using a function machine. So you should know how a function machine works so that you can tell which is correct and which is not. Okay? Is this clear? Hafsa?
Yeah.
Okay. That's it for today. Okay? Tomorrow, inshallah, not tomorrow, Monday, we shall start off with the stretch, and then we'll see if we have enough time, and then we will do all the combined transformations together. We'll talk more about the function machine, because once we have studied all the transformations, then we will see what this is. Just reflection and translation combined. Sometimes you have to combine reflection with the stretch, reflection, horizontal translation with horizontal reflection. This is horizontal translation with a horizontal reflection. Sometimes horizontal reflection with vertical translation. So you can have many combinations together. So we will look into the combined transformations in the final class, which will be, I believe, on Tuesday. Okay, done. That's it. Thank you very much. Allah Hafiz.
Hafiz.